Over the last decade, communities across North America have felt increasing effects of wildfires and smoke. Fires are behaving in new ways, and it's critical that scientists develop tools to respond effectively to wildfires and to safely conduct prescribed burns. The FASMEE project is an opportunity to do that. Today, managers are conducting an unusual high-intensity prescribed burn to restore aspen forests. Researchers are using this unique opportunity to collect data to improve fire modeling and forecasting.
This is a culmination of starting a project in 1998 when someone said, how do we know where we need fire and when we need fire, and how do we get to the answers? And here we are this many years later with some of the people who can help us be more precise about that.
And we want to get fire back into the ecosystem and try and get aspen regeneration. We want to apply fire through 60% of the unit. We want to burn 90% of the mixed conifer.
We realized that we could get help by asking research to come and work with us. Our perspective is that the forest is a lab. We're lighting it anyway. The lab's open.
We are here to collect data from the ground all the way up to space platforms to improve the models that are used for making decisions to plan and conduct prescribed burns and respond to wildfires, and to make better science-based decisions about managing ecosystems.
FASMEE provides a rare opportunity for scientists and managers approaching the same questions to coordinate, share data, and build relationships.
So one of the reasons I'm excited to be here on the Fishlake today working on this prescribed fire is that it's a very large, high energy, intense prescribed fire, which is very unique in the prescribed fire world. We don't see a lot of those. And so these types of fires give us a unique opportunity to test our aircraft and our sensors in an environment that approximates what a wildfire might look like.
Knowing the location where the burn was going to go, researchers could go in weeks or even months before the burn to collect data pre-fire, knowing that it was going to plan to be burnt this fall, and then come back probably next summer to resample those plots.
Here at NASA, we're collaborating really closely with the Forest Service and bringing in our aircraft and our satellite observations to improve what they're doing, and then what they're doing also, the data they collect helps us improve our techniques and our algorithms.
The sampling we're doing right now is to go along with the ignitions of the prescribed fire so that we have an idea of the fuel moisture content that's being burnt right now, so we can pair up that fire behavior with how much water is in the fuels.
So it's an opportunity for us to realistically measure the properties of wildfires before, during, and after, but using prescribed fire, so we can do that much more safely.
They're measuring ecosystem properties, vegetation properties on the ground. They're measuring fire behavior on the ground. And we're doing that moderate scale right now, the in-between with our aircraft. And then eventually we'll be able to link that up to another higher spatial scale and do that from space. So eventually we'll have satellites in orbit that we can take these measurements repeatedly across the globe to help with fire management and fire science.
Managers, from district rangers to engine captains, are investing in this partnership. They use complex models to assess risk, understand how active fires will behave, and forecast where smoke will travel.
Fire and smoke models try to describe the physical processes that are going on here, but those models can really be improved by accurate measurements. And the FASMEE project here is very much about collecting accurate measurements before, during, and after the fire, and at multiple scales.
They say that all models are wrong, some models are useful, and the important thing is to realize the limitations and assumptions to each model, and they can help inform you, but you still need to be able to ground truth them and actually see what's happening on the ground.
So the more information that the researchers can get and develop out here, the more that can feed to us, and the more we understand what's going on, and the safer and more effective we can implement fire on the landscape.
The models are used from everything from the fire behavior analyst, who is looking at what sort of fire behavior you can expect, to the firefighter on the ground who's slinging weather and coming up with a probability of ignition that you might get a spot fire in this location, to the agency administrator that actually has to approve the burn plan and tell the burn boss to go ahead and light the burn.
Bravo Hotel
Yeah, we are off Richfield and route back to the South Monroe. We have two souls on
FASMEE brings together researchers and practitioners, modelers and end users to support the co-production of the fire science tools we need for the future.
I've been working really closely with Susan O'Neill on this project. She's a Forest Service researcher, and I'm more of an operational type person making decisions about proposed prescribed fires and how to limit the smoke impacts. And Susan is the architect and the designer of one of the few systems that can help answer those questions in advance. It's called the Blue Sky Framework.
We're seeing more and more wildfires burning in the western U.S., and we see smoke impacts not only in the western U.S., but we're seeing them in the eastern U.S. And so studies like this will help us better understand smoke transport and dispersion, and then also help us improve our modeling ultimately to predict where the smoke can go.
And the additional science that is being done here at FASMEE is going to make all those tools a lot better.
And these models get used by agencies across the U.S., and in particular they also get used by people deployed on wildfires doing smoke forecasting, known as air resource advisors.
Results from data gathered today will be used for years to come, improving our understanding of fire and smoke, supporting managers and practitioners, and benefiting everyone who lives with wildland fire.
So today, collaborating here, we have a huge variety of people. If we didn't have FASMEE as a way of doing business, we wouldn't have that group of people who can facilitate learning quickly.
A project like this involves not only people traveling from all over the country, but also coming together to work on a complex, intense prescribed fire. So it's got a lot of challenges, but when it all comes together to create a coordinated data set, that makes it especially rewarding.
One of the things that we heard from practitioners is this real need to push towards 24/7 thermal observations of active fire. Right now, we have satellites in space where we might be able to get 2 to 4 looks at a wildfire today, which is really not sufficient for operational fire management. So some of the things that we're doing today is testing out new sensors or new platform configurations so we can push towards this 24/7 observation of fire, and I think we can do it within the next 5 years.
Talking with those folks and understanding their development process and them understanding our operational needs is really exciting.
It's important to have that connection between management and research so that we can stay up on making the best informed decisions and applying science so that we can be responsible.
If we called it the shortest way possible, we would say we're learning and burning. So all of us are learning while we burn collectively together to create a data set that helps us learn even more.